to Amazon RDS, and I'm delighted to introduce our speaker today, Anel Perez, Senior Solutions Architect.
Great. Thanks everyone for joining me here today. And as Jan mentioned, we're going to talk about migrating SQL Server to Amazon RDS. A little bit more background on myself. I've actually been with AWS a little over 5 years, and I actually support our public sector customers, specifically in higher education in New York City. And I have worked with some of our customers supporting Microsoft-based workloads. I've probably been supporting Microsoft workloads for closer to 8 years or so. So we'll dive right in. What we'll cover today are 3 things. What are the benefits of migrating SQL Server to Amazon RDS, assessing and planning your SQL Server migrations, and also we'll dive deep into the options for migrating SQL Server to Amazon RDS. What we won't be covering today are basics of operating and administering SQL Server, basics of Amazon RDS or refactoring SQL Server. The intent is to give you as much information as possible to move your self-managed on-prem databases to our fully managed Amazon RDS. All right? So here's our agenda for today. We'll start by talking about why you would like to migrate your databases, options for running your databases on SQL, options for running your SQL Server on Amazon AWS, migrating SQL Server workloads, specifically the 3 main options, which are SQL Server Backup and Restore, SQL Server Replication, and Database Migration Server. So the 3 big topics we'll cover, and then we'll wrap up at the end. As Jan mentioned, if you have any questions, feel free to go up to the mic, ask a question. More than happy to spend a few extra minutes diving deep with you all. Okay? So, why migrate your workloads to AWS? For many of our customers, they spend a lot of time doing the day-to-day maintenance of these databases. That includes the storage, the maintenance, patches, and the backups. One of the main benefits of using Amazon RDS is that all of this is fully managed for you. When you run this service, we're automating your patches, automating your backups, and you can do single-click high availability. So business drivers for migrating to the cloud vary from customer to customer. It could be cost savings, it could be trying to consolidate your data centers, it could be around your backup and DR strategy, digital transformation, all of the above. So yesterday, my customer was here, so New York University, and I'll share this anecdote with you all. And we began doing a data center closure with them about 2 years ago, 2.5 years ago, I'll say. And their initial driver was, A, they had to get out of the data center that's inside of Manhattan, and also reduce costs. One of the unlikely things that we discovered while we were doing the migration is that the speed at which they could actually operate in the cloud significantly improved their DR strategy. To give you an example, they have a large financials app running on a database, and they would do this yearly DR test, and that DR test would take them to restore this one application around 280 hours. Their recovery time objective for that same application was actually 7 hours. When they moved to AWS, they could restore that same application in 2 hours. So you may start with one initial idea or goal, but quickly you'll realize that there's many benefits to operating inside of the Amazon AWS infrastructure. So once you're ready to migrate, you may be wondering, okay, how do I get there? What are the tools available to me to help me get there? We have a wide range of tools available to you, and I'll pick a few just to talk about them. So for example, on the left-hand side there, you see the Cloud Adoption Readiness Tool, Application Discovery Tool, and even Migration Evaluator as well. And these tools are designed to not just assess your current environment, but also help you analyze your current business processes that you have to see if you're ready to even migrate to the cloud. So these are tools that are available for you for free inside of your AWS account. You can look at them. Some of these are just websites you can click on. What I'll mention as well, at the end of the presentation, I do have a QR code. So any links that I share or references that I make will be available to you at the very end of the presentation as well. So I see phones coming out, which is great. Take it out later. I'll call it out once I have the QR code up there. Some of the tools that we see customers leveraging quite a bit when it comes to migrations are the Migration Hub and our prescriptive guidance page. Really popular tools. Migration Hub is going to be your one-stop shop to be able to monitor and manage your overall migrations to AWS, and it ties into many of our other AWS services. Prescriptive guidance is actually a web page on our website that actually has several documented use cases. It talks about some of the personas you need to actually be able to do these very specific workloads. And we actually do have several papers on there on migrating SQL, not just to RDS, but also EC2 and other database engines as well. So let's talk about running SQL Server on Amazon RDS. To start, Amazon RDS, as I mentioned earlier, is a fully managed service that runs on the AWS cloud. You can have up to 128 vCPU, 4 terabytes of RAM, and up to 16 terabytes of storage. And in terms of storage, you could also use our Provision IO, IO1 volumes, give you up to 64,000 IOPS. And if you're looking for that level of performance, that's actually going to be our DB-X1E 32X large instance type. We support SQL Server Express, Weber Standard, and Enterprise. There's a wide range of instance types that fit just about any workload. We do believe that there is a right instance type for your particular job. So if you folks have any questions about any of that, definitely reach out to your AWS account team. If you don't know who that is, my email's at the end. Definitely reach out to me. I'm happy to answer any questions as well. And with regard to storage, you can leverage our GB2 or IO1 storage for your database. So I can't talk about migration without mentioning the 6 R's. Today, our focus is primarily going to be on rehost and replatform. I'll quickly summarize this for you in case you're brand new to this. So retain and retire are when you actually keep either the existing infrastructure you have today, or you actually completely decommission any infrastructure you have. Replace is when you're just going to let it replace that hardware. Rehost inside of AWS means that you're doing a lift and shift to Amazon EC2. That's what's highlighted there. The purpose of our discussion today is going to be focused entirely around replatform or refactor, like some people replatform, to Amazon RDS. A refactor would be when you actually want to move from one database engine to another. So for example, if you have Microsoft SQL today and you actually want to move to an open source database engine like MySQL or Postgres, that would be a refactor of your database. Like I said, we'll be focusing primarily on a replatform. So now let's talk about migrating SQL Server workloads to Amazon RDS. So as I alluded to earlier in the conversation, you really have 3 choices here when you want to migrate databases to Amazon RDS. The first one, SQL Server Backup and Restore, that's using native SQL backups. The second is using SQL Server Replication, which is the native replication built into Microsoft SQL. The third option is going to be Amazon Database, AWS Database Migration Service. And we'll dive deeper into each one of these right now. So many of you may already be familiar with your traditional SQL backups where you have that .bak file and you use that .bak file to either restore to a previous point in time. And you can actually leverage that same file to do the same thing inside of AWS. And you have 2 options for doing that. So at the top, we have Amazon EC2, which if you recall, that's going to be your rehost, so lift and shift. But since we're talking about going ahead to replatform your database, you could also leverage RDS to go ahead and do that for you. And remember, the advantage of RDS is that you don't have to worry as much about patching or maintenance of your databases. Your teams can focus on other things like improving the performance of your applications or actually adding additional functionality to those particular applications. I do want to spend some time talking about this very specific process because there are some steps that are required in order for you to do this. So, for example, when you first start doing your migration using this particular pattern, you actually do have to start with a full backup to load the data into the database. So many of our customers may start with either a weekly backup, or if they do daily full backups, that's your first place you want to start. You want to take that backup and you actually want to copy it up to AWS. We have a whole array of storage solutions, which I'm going to talk about in a few minutes, where you can dump that data into. And then you actually want to do incremental updates of that data or refreshes. So that's when you take the differential backups, do the same thing, upload them up to AWS, and there's a series of SQL commands that you would run inside the SQL Server Management Studio to actually go ahead and load that data into Amazon RDS. All right? There are some requirements though. So on the RDS database, you have to enable what's called an option group. And all that option group really does is give you the functionality to run a very specific SQL command, SQL query, to go ahead and load that data into your database. Okay? So going from left to right here, we're going to start with Amazon S3. Amazon S3 is going to be your primary data store for actually importing data into RDS. I just mentioned that option group. That option group specifically allows Amazon RDS to go ahead and pull data from S3. So that'll be your full backup, your differential backups, and also your transaction logs. Okay? And if you're not familiar with Amazon S3, it's an object-based storage solution that's built on top of AWS. Some things I would like to mention to you all today is that there are some limitations that you should be aware of. So for example, the largest individual object size is 5 terabytes. So if you have SQL backups that are larger than 5 terabytes, you actually have to do what's called a multi-file backup and do a multi-file restore. So at the end, I do have links for this, that QR code that I mentioned, so definitely reference that information if you do have backups that are larger than 5 terabytes. That would definitely be applicable to you. Also keep in mind that Amazon RDS has a maximum size of 16 terabytes, like I mentioned earlier. So if you have databases that are larger than 16 terabytes, that's probably a candidate for either EC2 or an actual re-platform of that actual solution. So moving that database from, sorry, not re-platform, a refactor of that database from one database engine to another, because our other database engines actually support up to 64 terabytes compared to 16. Okay? So then we have our Snow family. That's going to be Snowcone, Snowball, and Snowmobile. So these are options for offline restores. I do have some additional slide decks that go into detail, and I'll cover those in a moment. And lastly, we have Storage Gateway and Data Sync. These are going to be your primary tools for moving data from your on-prem data center over to AWS. Storage Gateway comes in 3 flavors. We have our File Gateway, we have our Tape Gateway, and we also have our Storage Gateway, our Disk Gateway, Volume Gateway, Storage Gateway, File Gateway, yes. And then we have Data Sync. Data Sync is actually going to allow you to connect it to an existing file share inside of your data center. And whenever you upload data to that file share, you can have Data Sync automatically move data into your designated S3 bucket. And I'll cover these in detail in the upcoming slides. So the first option we're going to talk about is using Storage Gateway to move your backups up to AWS. The advantage of Storage Gateway is that it operates with traditional SMB, NFS, and even Amazon S3 API calls. So if you're familiar with existing file shares, I'm sure many of you have them in your own environments, you could actually leverage Storage Gateway. It comes in 2 flavors, 2 forms, I should say. You can either have a physical appliance that's actually installed inside of your data center, or you can have a virtual machine that's running inside of your environment that could act either as a storage device via like a volume, via iSCSI, or even a file share where you could actually dump your backups into that location on-prem. Looks completely like every other file share, but behind the scenes, the appliance is actually going to upload that data up to AWS to the S3 bucket that you specified. The nice thing about Storage Gateway is that it has encryption in transit as well too. In the middle, between the 2 environments, your corporate data center and AWS, you'll see that we have Direct Connect and VPN. These are optional, so if you want to route the traffic over a private connection that's going to be more reliable than the public internet, you could definitely do that. Or if you want to add encryption on top of that via the VPN tunnel, that is also an option for you too, although it's not required. Okay?
Are you taking questions now?
Yeah, if you want to walk up and ask a question.
So, is this scenario is not going to support, transactions still occurring? Like, this is okay, but what if you need your database up and running and still receiving transactions on your on-prem stuff, right?
Absolutely.
Right? Okay.
I know exactly what you're saying. So thank you for raising that. It's a valid point. So one of the disadvantages of going with this particular migration pattern, so we're talking about using the native SQL backup and restore functionality, is that you're not capturing those changes in real time because you're not always running backups all the time. And even the time it takes to upload that data is significant. So one of the things that I could mention, what we see customers doing in the real world when they want to do a cutover using this type of methodology, they actually go ahead and make their on-prem the read-only, and then they point everyone to the AWS database, and then they do the last differential backup, then move that backup over, and that'll bring everything up to speed. So that's the common pattern. So In terms of doing what you're asking, where you want to do real-time transactions to Amazon RDS, that's going to be our database migration service that's going to do it for you. And I actually have a little demo, and I talk about it in detail. But just to give folks some context, it's a great call out, and that is one of the disadvantages of this methodology. You have to factor that in when you do your cutover.
Thank you.
You're welcome. Next, we're talking about data sync, and personally, I'm biased towards data sync. Is one of my favorite services. For me, it's the most efficient way to transfer data between your on-prem environment and to AWS. It has a really efficient way of aggregating data together and sending it in batches over to the S3 bucket. And if you have, there are ways to optimize S3 to get more efficient performance too. So, for example, if you're using prefixes to create data structures inside of your backups or your files, whatever you're uploading, data sync is really efficient. When it says transfer data at speeds up to 10 times faster, that is no joke, and many times it exceeds that. It's really powerful. What I'll say that's really nice about data sync as well too is that you can schedule these jobs, let's say you don't want to do this during peak times and saturate your utilization of your network connection. You could even do bandwidth limits on the actual transfers as well, and you can schedule when those bandwidth limits are lifted or they go down. So it's really granular in terms of the functionality it has and the ability you could use to transfer data to AWS. But very similar to Storage Gateway, you would actually point us to an existing on-prem file share where you're actually already putting your full differential and transaction logs. And then behind the scenes, it will actually go ahead and place that inside of an S3 bucket where you can then run your SQL statements inside of SQL Management Studio to then import that into S3. Oh, sorry, import that into Amazon RDS. Apologies. Right. Then there's the offline scenario. So let's say you have a data center that's in a remote location, has really low bandwidth, or you just don't have a good mechanism for actually transferring the data online into AWS. That's really where the Snow family comes in handy. So as you'll note here, the architecture diagram mentions full database backup. Hypothetically, you could do your incrementals using Snow devices as well. I mean, I've seen customers, if they're able to get the device out same day, about a week or so turnaround time to get it inside of your S3 bucket. So it is possible to do incrementals, but your data is going to be severely delayed from the time that you do that last incremental, the time you do the cutover. So definitely factor that in if you need to do an offline backup restore option. So for those of you that are not familiar with our Snow family, we essentially ship to you a physical hardware device. It's a storage appliance, and it can have compute associated with it if you need it. Snow Cone being the smallest one, and then we have Snowmobile and Snowball Edge as well as options. And on the device itself, it actually has a shipping label, so all you really have to do is take that device, plug it into your physical server or your network environment, upload your files, and then ship it back, and the label will be prefixed already on it, and UPS can just pick it up and ship it directly to our data centers. It goes into an S3 bucket, and the data is available for you right there. So in terms of what that looks like, that device will go in transit, like I mentioned. You have the backup bucket, and then once you have it inside of that bucket, once again, you would issue the same SQL query to go ahead and import that data into Amazon RDS. And I have examples in the links at the end. SQL Server replication, so this is another option for you. What I really want to highlight here is that first bullet point. That's really important. So SQL with RDS only supports transactional replication as a subscriber only with a push subscription. So if you're wondering what that is or what that details, I do have a link that outlines that, points to a Microsoft doc that gives you all the information on that. But that is the only way that you're able to do this within Amazon RDS. Also, I'll mention that this is only recommended for one-time migrations. So if you're doing a bunch of updates and changes, it's not ideal. It's not the fastest way to do it. It's not the most efficient. And you will or might see some discrepancy in your data between the source and the target. Right? But the idea is that you would actually log into your SQL Server. You'll configure your database to be both a publication and a distribution for that particular database. And then you would connect that to RDS. And then behind the scenes, there would need to be a network, some type of network connectivity between your on-prem infrastructure and the Amazon cloud. So that means either a VPN or direct connect will need to be pre-established before you even consider this path. Unless your SQL Server is out on the internet, then that's doable, but I don't know any customers running SQL Server on the internet. So that's definitely an option as well too, but we do recommend that you use VPN or Direct Connect for actually transferring the data via this replication mechanism. Okay. So the third option, and the final option that you actually have for migrating data into AWS, Amazon RDS specifically, is our AWS Database Migration Service. Really powerful tool, and I'll share a story here too. Some folks know that we were Oracle shop. We had a bunch of Oracle databases, and about 2 years ago, I want to say, we made this big push to actually move all our databases off of Oracle into our native products. When we did that, we had to develop a lot of the tools to make it happen, and that's really where a lot of the experience came for the AWS Database Migration Service. When we actually finished moving our last database, we did a big party. That's how big of a deal it was. And I actually personally like this service a lot. I have a little demo for you as well too. But the idea is that this is a fully managed service that allows you to maintain both your source and target in real time, replicating data between the two. So aside from doing just a big bulk full initial load into your database, it can actually detect in real time whenever there's a change to your source database and move that to the target. And that's what I have in my demo for you. So in terms of what the architecture looks like for AWS DMS, you start off by logging into the AWS console. You have to actually configure your endpoints, and think of your endpoints as your connections between your source and target servers. So there would need to be some form of network connectivity between the two. So if you have your on-prem data center, that means you need to have a VPN or Direct Connect to be able to talk to the AWS DMS service. This service has a public endpoint, so if you talk over the internet, there is encryption in transit, so you are protected, but you can also wrap this inside of a VPN or Direct Connect if you chose to do that. In terms of what's actually doing the heavy lifting for you, there's a DMS replication instance that sits in between the two. So that's really doing the orchestrating, doing the migration task, and actually looking at your source and seeing if there's any changes that are being made, and then replicating that data over to the target server. Okay. So one of the big benefits here too is that if you don't want to load an entire database, you want to do it slowly over time, you can set up several migration tasks, and you can actually have it load that into the target. Table by table, or if you want the entire database, you can, but we definitely have customers that have large databases that see value in moving individual tables, and the main reason for doing that is if you have a lot of interdependencies between your applications and you want to move applications little by little to the cloud, this is one mechanism for doing that. You could actually, instead of doing a bulk import and perhaps breaking a bunch of apps, you can just do table by table, like I said. So the onboard replication phase on the actual DMS instance there is going to actually look for any updates, changes, any deletions on the source target, and actually replicate that over to the destination. This is optional. If you don't want to do that, you don't have to turn it on. There are a few checkboxes that you can knob and tune inside of your database. However, when you see the demo I'm going to show you, I have a video of a change happening, and in real time, I'm querying that same database, and you're seeing that change being replicated. So, how does this apply to you in the real world? So let's say you start off with your database, your users are connecting to it today, just like they have every single day. You connect to that source database, everything's good in the world. But you have this larger goal of wanting to move your database to the cloud, let's say specifically Amazon RDS, because you don't want to worry about the patching, the maintenance, those everyday tasks that don't add business value. So what the AWS DMS service allows you to do is select those tables, those schemas, those databases that you want to move over, and establish that connection with AWS. So once you have that initial data load and you want to do your actual cutover, what that means for you is that instead of your users then connecting to that on-prem database, you can point them straight to your Amazon RDS database, and they can continue operating and working as if they normally would, without any disruption, without them noticing any difference, except that now instead of pointing to an on-prem database, you're now pointing to a database that sits inside of Amazon RDS. So the one thing I'll mention here as well maybe you're thinking in the back of your mind, all right, so DMS sounds great, it sounds amazing. What's the catch? What do I want to know about this? What can it do? So what I'll share with you is that we have other tools to help you do this, but one of the things that is not captured, or one of the few things that isn't captured by DMS, are things like stored procedures, things like any special scripting you have that's happening inside your SQL database. So the advantage of using a .bak file is that it captures everything, including those stored procedures. DMS cannot natively do that. If you want to capture things like stored procedures, you have to use what's called our schema conversion tool, SDT, and that will capture your actual stored procedures, among other things, inside of your database. So definitely keep that in the back of your mind if you're thinking about moving these databases. It captures the data inside of the databases primarily. All right. Now it's demo time. So fingers crossed, let's see if it works. Yes, it's working. Okay, cool. So this is the AWS console right here. This is the database migration service. What you're seeing here is the main landing page. You can see that I actually have one active migration task that's there, and that's constantly monitoring my source database. I have a few different endpoints too. I have a source and a target endpoint. I'm gonna click into this, and here you can see where I have my target and my source servers configured. In this particular configuration, my source server actually lives inside of Amazon EC2, so it's not a full data center. I'm just simulating it by using an EC2 instance. And inside of the endpoints, we configure all the connection properties for your database, whether or not you want to use encryption, the IP addresses, the credentials to actually go ahead and capture that data. That's all specified inside of this endpoint section of the console. And then the replication instances, this is where you pick how large of an instance you want to actually do the heavy lifting for you. Typically, you want something that has a large amount of memory. The more memory you have, the more data you can load at once. And you can actually capture and see these metrics because it's inside of CloudWatch. You can see how much is being utilized over time, and if you bump it up within a few clicks, you can bump it up to a larger instance type if you needed to do that. Your migration task is where you specify what type of migration is it. If I just want to do one-time loads, or if I want to continuously monitor the actual database. In this scenario, I am monitoring the source database to replicate those options, those changes to the target. And even within the migration task, you could have filters applied, so you're only doing specific tables or specific schemas if you want to do that as well. And here I'm clicking through that. So here you can see that my database has actual data. This is data from the source tables. I have a bunch of rows preloaded in there. And that's back to the details page. I should pivot pretty soon to the instance. I'm actually logged into a database, the source database, which is on Amazon EC2. There it is. So here I have a SQL query that's just pointing to a CSV file to load a bunch of tables. And I'm gonna point to the target server. I'm gonna run a query to look up how many rows I actually have. Any second now. There we go. And when I execute that query, you'll see that 2 rows are returned. And again, this is on the target. This is Amazon RDS right here. I already did an initial load of the data. There we go. There are my 2 rows. Now I'm going to go back to my source, and I'm going to run that query to actually load some additional data on my source. All right. Success. Now I'm going to go back to the target, run the same query. There's more data. Pretty instant. Of course, it's going to vary based off the connection speed that you have. That's why we recommend using something like Direct Connect. Direct Connect will give you dedicated bandwidth to your AWS VPC. However, you could replicate this very easily inside of your own environment. At the end, I do have links with workshops and guides that walk you through the same exact demonstration I just did here. You can replicate yourself and do it. Any questions, folks? Okay. Awesome. So this is it. Whip out your phones, take a picture. This is the link. It points to a GitHub page, has a bunch of links, even some miscellaneous things that I found to be really useful when you're looking at migrating your SQL databases up to Amazon RDS, including some workshop guides. So if you actually want to do the same exact exercise I just did, you can do this yourself. I'll give folks a few minutes, unlock your screens. I know it's difficult to face mask typing your code. so liberating having to go. It's nice. Question?
Yes, so even with the DMS, we're talking about data migration.
Mm-hmm.
But what about the cutover? I mean, the point here is eventually migrate your applications, everything. How do you manage the cutover so your servers talk to the right server? And do you have a facility to do it as data moves? So for example, let's say you migrate by geography, by state, and you have the state of Maryland already migrated. Do your applications know that you don't need to already go to the source, keep your transactions there because all your data is already on Amazon? And
Yes, happy to repeat the question. So, correct me if I'm wrong here as well. So you're asking if you have a large environment that spans across multiple states, right? And you want to be able to manage the cutover between those production databases that sit inside of a data center to an Amazon RDS database, for example. How would you go about doing that? All right?
yes, but I'm not saying that the data is partitioned by state. There is data.
Yeah, users accessing it from different locations.
Right.
Gotcha. Okay. So there's a few different things here I want to mention. First, Amazon RDS primarily operates using DNS. And we like DNS at AWS because when you talk about high availability, you want to treat those individual resources like ephemeral resources. If there's an issue with a database server, let's say a disk crashes or the operating system crashes, you want to be able to fail over really quickly without interrupting the actual applications. And that's really the power of DNS. So when you provision Amazon RDS, you are provided with a DNS endpoint. So this is all hypothetical, right? So let's say you wanted to manage who's connecting from where to that DNS endpoint. You could use our Amazon Route 53 service to manage those connections. You could tie it by geography if you wanted to, or from source IP, and say, okay, if you're coming from here, route my traffic to this endpoint. And there's even ways to create RDS proxies where you could actually have it go to specific database engines if you wanted to as well. So you could have traffic going to 2 different places. Keeping everything updated at the same time might be a little bit of a challenge depending on how large the database is, but hypothetically, it's possible. And I have my email here, send me an email. Happy to talk and think through it with you. Does that help answer? Okay, sounds good. Awesome. So let's talk about some key takeaways here. So when you're considering moving your databases to Amazon RDS, some of the same limitations live whether you're on-prem or inside of AWS. So for example, you can't have a backup file that is newer than the database engine that you're migrating to. So for example, or say older than the database, newer, yeah. So for example, if you had SQL Server 2012, for example, and you actually want to take that backup file and move it to AWS, you can't take that 2012 backup and move it to 2008, for example. It needs to be that database engine or newer, so definitely keep that in mind. And for many customers, this is a great opportunity if we have a database that's maybe not supported inside of Amazon RDS to actually migrate that to a newer database engine as well and take advantage of patching and the benefits that you get from having a newer database engine. Authentication is a big piece of it too. So when you're talking about how do I authorize access to my applications with Amazon RDS, you actually can use either IAM or local database authentication. Many DBAs like database authentication because they're used to it, but you can use AWS IAM as well in addition to that. The amount of data is really going to be pivotal to how you achieve success here. So, working with my customer, NYU, who presented yesterday, we did it in phases. We planned everything out, we moved into waves. We moved non-critical, QA, non-prod databases first, and we did it table by table. We said, okay, these applications, look to these tables, let's move these tables first. And the reason we did that is because we didn't want to break any dependencies that other applications have. And key to our success there, it took us about 2 to 3 years to get there, was that we did a very intensive discovery using AWS tools, and we had to map out all those dependencies between those applications. So we knew if we move this application, we're not breaking something else. So that's definitely very key, understanding the amount of data and also the interdependencies between that data. Connectivity to AWS, important like I mentioned. So if you want the fastest, most reliable connection up to AWS, Direct Connect is definitely going to be your answer. Is it required? No, you can use VPN, use other methods as well. but that's going to give you the best bandwidth, the best speeds up to AWS. Also, you have to decide, do I want to rehost your platform or refactor? You know, a big part of that could be retired too. Like we have this database that's aging, you know, we don't really need to keep it. We can move these tables to another database, and you have flexibility in making those choices and retiring existing hardware to fully maximize the amount of CPU and memory you're utilizing, because that's the key, right? You don't want to over-provision your resources. That's not what the cloud is about. You want to have the right amount of CPU, the right amount of memory to meet the demand of your workload, right? Then the migration methods. So we talked about 3 today. Those are the 3 main methods that we see moving SQL databases. So just to recap, that's going to be the native SQL Server backup and restore. That's going to be the ongoing SQL replication or AWS DMS. Those are the options. And of course, if you feel like you need help with any of this, we have solutions architects that are here to answer questions like myself. Happy to spend some time with you all. Also, we have professional services and partners that are available to help you achieve your goals. Highly recommend doing the well-architected framework on your applications. So we have compiled some best practices based off our experience working with customers. We call that the well-architected framework. This is a self-service tool that you can do inside the AWS console. If you have questions, reach out. Happy to answer some questions around that. And then optimization. That's a continued journey for you. It's not like once you move to AWS, it's all said and done, everything's gonna be great. There's still gonna be ongoing work, optimizing your workload, making sure you have the right memory, right CPU, making sure that you're right sizing. That's a big part of it. And even as we release new instance types and new features, you start thinking about, okay, how can I use this feature to actually make my job easier or give a better experience to my end users? Yes?
So one of the scenarios, those scenarios you went over, would one of the scenarios could be a hybrid? Like would one of them be a hybrid where you use the backup pattern and
For that initial load to get your stored procedures, for example, and then do TMS?
like use the backup pattern and then use RDS, the migration services as a cleanup or just to maintain the transactional form, like the delta of the day or two that might be right.
Yes, so to repeat his question, he's asking if it's possible to do a hybrid of 2 solutions, specifically the native backup and restore option and using the database migration service, right?
Yeah.
Awesome. So yes, that is possible. What you would do, you would take that initial full load from that .bak file, and there's actually value in that, right? Like I mentioned, you get those stored procedures, you get those SQL scripts right from that .bak file. So if you want that, you can definitely go with that path first. Keep in mind that that .bak file is probably going to include everything, unless inside of your query to run the backup, you're excluding certain things, but it'll have everything in there. And then you can do incrementals using DMS. That's entirely possible, for sure.
Have you had any customers do that you can recall?
No, yeah. My work with, so just to give you some background on NYU had close to 1,500 servers. They closed a data center, moved most of it up to AWS, and with them, we use a combination of Cloud Endure and DMS. So Cloud Endure was for a lot of their lift and shift, and DMS was for a lot of their database work. We even had some Oracle stuff, so for that we used Golden Gate and the like. So it was a mixture of tools, but no, we didn't cross-pollinate that way.
So they use DMS?
They did use DMS.
Yeah.
Yeah, and they still use it. So DMS is also a great tool for refreshing data across AWS accounts. You could definitely do that as well too.
If you have a question, raise your hand. I'll bring the mic to you.
Great. Yeah. Oh, go ahead.
Of course, you'd be all the way over here.
Can we use DMS for ongoing replication?
So you can. So that database DMS instance will actually go ahead and monitor the source database, and any changes, it can replicate that data in pretty much near real time. The limiting factor is going to be the size of the instance, how much memory it has to capture that data, and also the network speed. So it can replicate data, depending how fast is really a variable, all those factors.
Yeah.
But if you need real-time replication, it's definitely, I would recommend it because all those factors I already mentioned.
Oh yeah, and yeah, thanks for that. And also we do have a requirement to replicate the schemas, like stored procedures, views, indexes, and like that, right? Can we use the schema conversion tool for that ongoing schema changes?
You can use the SCT, the schema conversion tool, for ongoing changes. It isn't set up in the same way that DMS is, where you have a migration task that's just monitoring sitting there. You have to do those executions, periodically. So you could schedule it, right? AWS, we're very big on APIs and automating things. You could have a Lambda function or some other automation that's triggering those SET jobs to actually go ahead and update those schemas if you chose to do that. Yes.
And it can be done between like, an RDS instance to an on-premise server.
Yeah, you could do the other way around. So SET doesn't really care about the destination. So if you want to go back and forth, you could with SET as well.
Thank you.
Yeah, no problem. Yeah.
Is there another question on this side?
Oh, sorry. Back to you.
Two questions actually. So the first one is if there's no connectivity between our
Data
data
center.
center and Amazon, is the only way to do it the full backup and then maybe try to get the incremental backup through S3 to minimize downtime? Because I know like we did as a test, we did a snowball, but that takes a week to get the data from the data center into
The bucket.
yeah. So if you want to minimize the downtime, like in production, how would you recommend? How would you recommend that? That's
Using the native SQL backup and restore.
yeah, because we don't have any, we won't have any connectivity between the on-prem data center and AWS.
Yeah, the best thing you could do is that option where I mentioned. You're gonna have to schedule some downtime. Unfortunately, there's gonna be some time in between where not all the transactions are gonna be up to date. Where you take the source database, make that a read-only, and start pointing people to Amazon RDS in between that time where you're getting the data migrated. So if you're able to plan and schedule that, it's gonna be your best bet. But there is really no, real-time way to do that with zero downtime using the native SQL backup and restore. You could do a combination of SQL backup and DMS as long as there's network connectivity, internet connectivity, or some other way of connecting. Like you do a quick VPN connection just to get that last transactional log and last incremental up to AWS, and that will help you minimize that time significantly. So do a full load using S3, Snowball, whatever you got to do, but then schedule that incremental as quickly as possible, and you could use DMS to do that as well.
And then the second question is, so Amazon does all the patching, right, with RDS. How long do you have to actually implement the patches? Because sometimes the development teams need time to say, oh, I want to test out with the latest patch. Like what kind of time frame does Amazon give you before you have to implement the patch or something?
Yeah, great question. So with Amazon RDS, you do specify maintenance windows, and those are typically weekly. And during that maintenance window, if any patches that need to be applied, or apply those patches. You can defer maintenance if you choose to do that. However, if you get to a point where you're so far behind, you'll get a notification inside of your account that says you have to do this and you can't defer it. So you will be forced to do it at some point in time. It's a fully managed database. We want to support our customers to the best of our ability. We want to make sure you're safe doing it as well. So we just want to make sure that you're aware of that fact and you can defer it, but you will be forced to do that.
Are there other questions?
So did you mention how large a backup file could be? What's the maximum size?
If with S3 using the backup restore option, we're talking about 5 terabytes.
Oh, 5?
5 terabytes, but you could do multi-file backups. In that previous QR code, I have a link that talks specifically about how do you do multi-file backup and multi-file backup restores.
There was a limitation, we talked about 16 terabytes. Does that ring a bell?
Yes,
What
exactly.
that number relates to? Thank you.
Yes, 16 terabyte is the largest Microsoft SQL Amazon RDS database you could have. If you have a database that's larger than 16 terabytes, EC2 can support 64.
EC2 is not an RDS.
So EC2, we're providing you with a virtual machine inside of the AWS infrastructure. So you're correct, it's not RDS. So you as the customer will still be responsible for the operating system maintenance, so patches and maintaining your database at the operating system level. EC2,
And
yeah.
that can be 16 terabytes?
EC2 can be 64.
Oh, 64. And
The RDS is 16. So
16.
that's, yeah, if your database is larger than 16 terabytes,
The backup files can be 5.
5 each.
Yeah.
We do multiple 5, yeah.
Thank you.
You're welcome. Great, so with that, we have a few more minutes, so please, if you have some time, I would appreciate if you give me any feedback that you have. Oh, one more question? Oh, sorry.
It's more of a
public service announcement. We finished this process about 9 months ago. And what you really need to do is start paying attention to how much you're using. When you're coming from a traditional data center, you put memory in, you put CPUs in, and it's paid for. But because this is a pay-for-service, you need to wrap some governance around what you're doing so that you go, because teams seem to keep 5, 6, 7, 8, 10, 20 different versions of their software, and wrapping some governance around that to say, hey, you're only going to hold this much, and you control your costs back down.
Absolutely, that's a great point.
Not much you get into the AWS.
Absolutely, that's a great point. So one anecdotal tool I'll mention, we have something called the EC2 Instance Scheduler, but it applies to RDS too. So what we did with NYU, they have a QA, prod, and development environment. So with the QA and dev environments, we actually schedule those databases to automatically get shut down when they're not using them. And that significantly helped them reduce their cost. And even with those non-production databases, they were doing apples for apples builds. So for example, let's say the prod database had provisioned IOPS for storage. You don't need that really for QA and dev. That's really expensive to do provision IOPS. So we had to make some of the design choices as we went. And there were lessons learned on both sides of the aisle, I'll say, but we're happy to work with our customers and help them find those optimizations. Me as an architect, my customers' goals are my priorities. So if they tell me, hey, I need to reduce spend somehow, I'm helping find ways to do that. So if you have an account team, highly recommend you engage them. They'll do the same thing for you as well. All right, everyone. Well, hopefully you found this session informative. There's about 4 minutes left. I'll let you break out early. I'll stick around in case folks have questions, and thank you for attending. You're welcome. You too.